most dramatic events in New York City in the 1960s was the construction of the World Trade Center. Design and construction would take years and the efforts of thousands of people. A project of this size created enormous challenges. Challenges that demanded the use of dramatic new engineering concepts. A wide variety of designs was considered. Final plans called for a complex of low-level buildings surrounding two 1,350-foot towers, the tallest ever built. Their great height was made possible by the use of load-bearing walls. Extremely tall buildings were traditionally inefficient, since huge amounts of interior space were taken up by structural supports and elevators. The Trade Center towers would overcome this problem. The exterior walls were designed to bear much of the weight of the towers, as well as all of the wind loads. The only internal supports would be in a central core of columns. Elevators would be placed in the shafts formed by the core columns. To further conserve space, the towers would be organized into 3 zones served by express elevators. Local elevators would run within each zone. These engineering considerations determine the tower's basic design: sheer symmetrical walls rising without setbacks. The site selected for the Trade Center was an old section of Manhattan's Lower West Side. The area housed a great number of small businesses, but the predominance of electronic stores caused it to be known as Radio Row. In 1966, demolition began. In all, 164 buildings had to be torn down, and generations of power, telephone, gas, steam, and water lines had to be rerouted. The site actually consisted of waterlogged landfill, which had accumulated over 2 centuries out of old wharves and debris. To support the great weight of the towers, foundations would have to be dug down 70 feet to bedrock, but the removal of water from this huge area would have caused a dangerous lowering of the surrounding water level, undermining nearby buildings. The solution was to construct an underground concrete retaining wall to surround the site. This was built with the slurry trench method, used for the first time in this country. A trench was dug down to bedrock, and a thick bentonite slurry was pumped in. The slurry was denser than the surrounding mud and dirt, and thus kept the trench walls from collapsing. As each section was completed, 25-ton cages of metal reinforcement rods were lowered into the slurry-filled trench. With the cage in place, concrete was poured in. Since the concrete had a greater density than the slurry was forced up out of the trench and could be used for the next section. In this way, an underground wall was built completely sealing the site. Excavation began. As each section of the slurry wall was revealed, workers drilled holes through the wall and casings were pushed through down to bedrock on the far side. Steel tendons were then inserted through these holes and socketed into bedrock, bracing the wall against external pressure. More than 1 million cubic yards of dirt had to be removed to make way for the Trade Center's foundations. The excavated earth was placed in the Hudson River adjacent to the site to create more than 23 acres of new land which was donated to the city of New York. The site presented another major challenge. The tubes containing the PATH commuter rail lines lay underground within the excavation area. The fragile tubes had to be supported in protected cradles while excavation continued around them. Throughout construction, the PATH trains carried 130,000 commuters daily. At no point was service interrupted. 7 stories down, bedrock was finally reached. Foundations for the towers could now be prepared. Concrete footings were formed and poured into bedrock. Massive assemblies of steel beams called grillages were laid on these footings. Each grillage would anchor one of the load-bearing tower columns. Meanwhile, orders were placed for the 200,000 tons of steel which would be needed for construction. Individual pieces were prefabricated and rarely interchangeable. Moreover, there would be no room to stockpile materials at the construction site. This created a tremendous logistical problem. Steel sections would have to arrive at the site in the exact order and at the exact time needed. To meet this challenge, Port Authority engineers used a computerized system known as Critical Path Method, or CPM. CPM would coordinate every aspect of construction, track the flow of materials, and minimize any delays. In August 1968, actual steel construction began. Kangaroo cranes, imported from Australia, were used for the first time in the United States. The cranes were assembled on top of the core columns. Each could lift 60 tons at a time. They would be the driving force behind the tower's construction. The cranes have the ability to jack themselves up 36 feet at a jump. As the walls grew to the height of the crane would hoist itself up, a neighboring crane would swing core columns into place beneath it, and construction would continue. 70 feet up at street level, steel trees were put into place around the perimeter of the towers. These trees would transfer the load of the exterior wall to the more widely spaced columns now anchored to bedrock. Construction of the towers could now proceed with great speed. 3 basic elements were used. 2 or 3 story high sections for the load-bearing wall, massive steel beams for the core columns, and floor sections to span the 60 feet between core and wall. Through the complex orchestration of these structural elements, 3 floors could be constructed in 10 days. its many engineering innovations, the Trade Center was cited as the outstanding engineering achievement of 1971. Shortly after the structural completion of the towers, the surrounding low-level buildings were finished. A final addition to the North Tower was a 360-foot television antenna erected in 1978.